question was, how can you tell if a graph is a function? You can tell a graph is a function from the vertical line test, okay? If I gave you a couple of different graphs and I asked you which one was a function, you would have to perform the vertical line test on all of them, see which one passes. What that means is, in order for a graph to pass the vertical line test, the vertical line can only hit the graph one time. If it hits more than once, then it fails. Number 2 is, what is the turning point or the vertex of the parabola whose equation is y equals x squared plus 4x minus 2? And what I did here was I plugged this into the calculator and then I put the table on here for you. So when you're looking for the turning point of something, remember all of your points are mirrored around that turning point. So the turning point for this parabola was -2, -6. All of those y values are mirrored around that one turning point. So the y value of -6 only appears once in the table. So you have to scroll around and look and find where that vertex is, where that point is that doesn't have a match, and that's going to be your turning point. So you're going to have to plug that into your calculator in order to figure that out. Any questions on 1 or 2? Okay. Number 3, Jesse wants to attend the town carnival. The price of admission to the carnival is $2.75, and each ride costs an additional 99 cents. If he can spend at most $26 at the carnival, write an inequality that can be used to solve for R, the number of rides Jesse can go on, and solve for the maximum number of rides he can go on. So basically, first you're writing the inequality, okay? So it's $2.75 to get in. So you're only paying that amount once. That's your y-intercept. And then 99 cents is your slope, because that's the cost per ride. Whenever you're using the word per, that's your rate or your slope. Now, this is going to represent how much money he spends. That number has to be less than or equal to 26 because he only has $26. So he can't spend more than $26. He can spend exactly 26, but not anymore. Then you have to solve it for the maximum number of rides you can go on. So I'm going to start by subtracting $2.75 on both sides. And when I do that, I get $23.25. And then you're going to divide by 99 cents on both sides. And when you do that, you get R is less than or equal to 23.48, and so on. Now it's asking for the maximum number of rides, so that's the biggest number that he could go on. He can go on 23 rides because that's less than 23.48. He cannot go on 24 rides because that is not less than. Okay, so 23 rides is your answer. Questions on that one? Okay. Next one, it says when 5g squared minus 2g plus 1 is subtracted from 2g squared plus 6g minus 8, find the difference. You're subtracting this from this. Okay, so the second thing comes first. 2g squared plus 6g minus 8. Then you're subtracting 5g squared minus 2g plus 1. I'm subtracting, so I have to use keep, change, change. So I'm keeping the first thing, changing subtraction to addition, and changing the sign of everything in the second pair of parentheses. 5g squared is now negative 5g squared. Negative 2g is now positive 2g. Positive 1 is now negative 1. And then I'm combining like terms. So the first pair of like terms are 2g squared plus negative 5g squared. That's negative 3g squared. Then I have 6g plus 2g, which is 8g. Then I have negative 1 minus 8, which is negative 9. My final answer is negative 3g squared plus 8g minus 9. The next one was to factor completely p to the fourth minus 16. Says that word completely. Okay? Yes, Brenna? Yeah. So when it says completely, often that means you have to use more than one factoring method. Definitely what that means is check when you're done factoring the first time if you can factor again. Sometimes they might try to trick you when you can't factor again. When you're looking at this, I have an even power and I have a perfect square. So that means I have difference of two squares. There's two terms, they're being subtracted, they're both perfect squares. I'm setting up two pairs of parentheses, one with a plus, one with a minus. The square root of each term goes in each spot here. P to the fourth, the square root is p squared. The square root of 16 is 4, not 8. Be careful on that. Now, once I factor that, immediately I notice that I can factor p squared minus 4 again. I can use dots on that bubble. So I'm keeping p squared plus 4. I can't factor that again because it's not a difference. P squared minus 4, I factor to p plus 2 and p minus 2. Okay, so you have to be careful that you can factor more than once if it says factor completely. Number 6, they gave you a table. It says the table below shows the yearly average balance in a savings account. No money is deposited or withdrawn after the initial amount is deposited. Which type of function best models the given data? So there's your table there, and they want to know, is this linear or exponential? And what type of rate of change is it? Positive, negative, and then if it's exponential, growth or decay. Right off the bat, you can see that the amount of money is going up. Okay, so you know it's not going to be a negative rate of change because the number is not going down. And you know it's not going to be exponential decay because, again, the number's not going down, it's going up. Now, what I showed here is I plugged in my calculator to see how much it was changing by each time. So for the first year, I figured out how much they added to the amount. So I did 620 minus 442, and the difference was 178.47. Then I did the same thing for the next section, and the difference was $335.83. And then for the next section, again, I did the same thing, I subtracted. It's changing by a different amount every time. If it was changing by the same amount every time, that would be linear, because linear functions have a constant rate of change. This is changing by a different amount every time, so it has to be exponential. So it's an exponential growth, because it's not going up by the same number each time. Questions about that? Okay. Number 7, what is the product of 2x plus 5 and x minus 5? You have to set up the box method here. And when you fill in your boxes, you got 2x squared, 5x, negative 10x, and negative 25. And then you're combining your like terms. So your final answer is 2x squared minus 5x minus 25 for that. Number 8, again, there's that word completely. So you're factoring once. Looking at this, I cannot use sum and product on this because I have an x to the third. So the first thing I'm looking at when I see factor completely is GCF. The GCF of this is x. Left over, I have x squared minus 20x plus 36. Then I'm using sum and product on that bubble because this says factor completely, so I need to factor again. The sum is negative 20, the product is 36. So you have to find a pair of numbers that multiplies to positive 36 and adds to negative 20. The pair was negative 18 and negative 2. This has an imaginary 1 in front of the x squared, so you can use your shortcut to factor that bubble. X minus 18, x minus 2, and then you have to bring down that x GCF from the beginning. Number 9, factor by grouping. You want to group the first pair of numbers together, find the GCF, which is x squared. Left over, you have x minus 3. carry down the sign in between. Same thing with the second two numbers. Find the GCF of 5x minus 15, which is 5. Your second bubble has to match your first bubble. So your second bubble is also x minus 3. And then your final answer, x minus 3. And then everything else, just like sum and product, x squared plus 5. Any questions on 1 through 9 so far? Okay. Number 10, the breakdown of a sample of a chemical compound is represented by the function f of x equals 500 times 0.75 to the t, where f of t represents the number of milligrams of the substance and t represents the time in years. In the function f of t, explain what 0.75 and 500 represent. I gave you these lines here. I did this on the test as well, because last time I asked you something like this, some of you only talked about one of them. So starting with the easier one, 500. 500 is the number out in front. That's the y-intercept. Now, they want you to talk about it in terms of the problem, so you can't write y-intercept, but you need to identify that in your head as the y-intercept. So that's the y-intercept, or the initial amount. So initial amount is what you need to say on your test. Y-intercept is what it actually is in the equation. Once you figure out that it's the y-intercept, you know the y-intercept is the initial amount, or the starting amount is good, anything like that. 0.75 is your multiplying factor in your parentheses. Now, your formula for exponential functions in the parentheses is 1 plus or minus r. Remember that? If it's going down or decaying, you're subtracting. So the 0.75 is equal to 1 minus r. So you need to figure out what the rate is, okay? What percent I'm going down by. If I end with 75%, how much did I decrease by? What percent? If I end with 75%, what did I decrease by? Jasmine. 25%. Very good. So my rate is 25%, and it's a decrease. If you weren't sure how to get that, 1 minus r equals 0.75, then you can solve for r by subtracting 1 on both sides. You would have ended up with negative r equals negative 0.25, divide by negative 1, and r equals 0.25 for your rate. So you have to say that it's 25%, and you have to say that it's going down. The next one is about the animal shelter. So an animal shelter spends $5.45 a day to take care of each cat and 75 cents a day to take care of each fish. Josh noticed the shelter spent $65.95 caring for cats and fish on Friday. Write an equation to represent the possible number of cats and fish that could have been at the shelter on Friday. So what I did is I said C equals cats, F equals fish, just so I knew what my variables were before I even wrote my equation. Then you're attaching the price. So it's $5.45 for each cat plus 75 cents for each fish equals the total amount they spent, which was $65.95. Cat price goes with the cat variable. Fish price goes with the fish variable. So that was part one, just to create the equation. The second part was that Josh said there may have been 12 fish and 10 cats at the shelter on Friday. That's why I wrote this down here so I know which variable is which. Are these numbers possible? Use your equation to justify your answer. So you're going to plug in 12 for F and 10 for C and see if it satisfies the equation. It's like you're doing a check. So $5.45, and there was 10 cats plus 75 cents, and there were 12 fish, equals $65.95. You can plug this right into the calculator, and when you do that, you get $63.50, which does not equal $65.95. So not only do you have to show that, but you have to say no. That's not possible. Then part C, later Josh found a record showing there were 11 cats at the shelter on Friday. How many fish were at the shelter on Friday? So now I'm going back to my original equation and I'm plugging in 11 for C because that's how many cats there were. I don't know how many fish there were, so that's staying as F. And I'm solving for F. So this is a normal equation here that you can solve. I'm not going to go through solving it. I'm just going to tell you that the answer is 8. You can solve that one on your own. And the work is on my answer tape. But I want to make sure I get to the last question. Questions? Okay, last question. You're plugging it into y equals. They gave you a function. This is what your y equals should look like. The same exact equation. Here's the table. I don't think there's enough room in your table on here for all of these points. I just did -3 up to 5 because I don't think there was enough room. But some variation of these points needs to be in your table. Then you're plotting the points on here. This question is really a freebie, guys, because I'm asking you to graph it. So don't get points off on this. You're just reading the points off of your calculator and graphing them. So that part was the easy part. The turning point, remember, same method of finding the turning point that we used on the other problem. Look in your calculator table where the y value doesn't have a match. Here it was 1, -9. It's also the minimum point on your graph, so you can also find it on your graph if that's easier for you. The roots, also known as the x-intercepts. Okay, that's where it crosses the x-axis, here and here. Also where y equals 0. You can find it in your table or you can find it on your graph. You only need to write the x values. If you can't remember that, then write the entire coordinate. The x values are -2 and 4. So you can write the coordinate. You can write x equals -2, 4. You can write -2 and 4 in curly brackets, however you want to do it. If you don't want to remember that it's just x's, just write the whole coordinate. Roots are x-intercepts where y equals 0, where it crosses the x-axis.